So, okay, here we go. So, I shared this a while back. I mean, I filed this issue filed this issue 2 years ago. 2 years ago, okay. So this is 2 years ago. 2 years ago. And the problem I think here is that there's this run HCS wcal configuration in containerd for Windows containers. We're talking about Windows containers here, okay? Now, when you run a Windows container, your Windows kubelet needs to schedule it, right? And before the kubelet schedules it, before the kubelet starts running, it has to be scheduled. It turns out that the scheduler does not use. There's a field called pod.OS, okay? There's a field called pod.OS, right? Pod.OS. Let me put it in the little streaming thingy, okay? So that pod.OS field, that's not used in scheduling. So you have to do a thing where you make a runtime class. Okay, so you do something like this. Let me show you. You go and I have an example here. So if you go to Windows here, it's in my GitHub. Okay, so if you go here and you go to smoke test here. Okay, so you see this taint here, right? See this toleration? That toleration, right? So you need that toleration to allow scheduling to a Windows node, okay? So that toleration right there will schedule you to a Windows node. So then what's this pod.OS kep all about? So then there's this other pod.OS kep, right? And that's here. And the pod.OS kep is all about security contexts and like the admission controller or whatever being able to decide at that point about what should happen if you're trying to run a particular pod. And so it needs to know, oh, this is a Windows pod. It's intended to be run on Windows. Okay, well, the admission control that I'm going to do for that based on the pod security context and blah, 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 blah. There's a whole science around how these pod security admission works. And that's what your pod.OS field, but your pod.OS, so pod.OS doesn't replace taints and tolerations. That's the thing to keep in mind here. So then what do you do for taints and tolerations to make it easier to run Windows pods? So what you do is you have to do a runtime class, okay? So a runtime class looks something like this. I'll show you. A runtime class looks something like this, okay? So tolerations. Let me commit this. I'm committing something in another window. Hold on. Yeah. So okay, you see this? See this right here, this runtime class? So what this runtime class does, okay, the runtime class will go and it will make it so that if you make a container, if you make a pod and the pod has this runtime class as the class that it is, right? So I just updated some code in here. So if I go and I say, I'm going to make a pod and I want the runtime class name to be this Windows whatever, to be this, okay, so that looks something like this. I'll show you in a real, let me show you in a real environment, okay? So if I go stop screen and then I share screen, I share my screen, I'm going to share my Termius with you, okay? So if I go and I look at this, this is an example of the pod.OS field in action, of the runtime class in action. kubectl get deployment, kubectl edit deployment, who am I? Windows. Okay, if I go in here, you could see I set a runtime class for this, right? Runtime. See that? So I set this runtime class, right? So when I set this runtime class, what it does is it automatically makes it so that this toleration is added to all my pods. Okay, so that toleration is always going to be added to my pods, right? And then that'll make it so my Windows containers are scheduled to these nodes, to these Windows nodes. Now, say I did something crazy, right? So like say I said like, you know, say I got rid of this toleration, right? I'm not going to do this, but say I got rid of this. Okay, if I did that, then next time I started a pod up and I said I want this pod to have the Windows 2019 runtime class, that pod would not have that toleration on it. And if that pod didn't have that toleration on it, then let's go look at this Windows pod, kubectl edit pod, this one. Okay, then this toleration that allows it to run on Windows wouldn't exist. And because of that, the scheduler would not try to land this on a Windows node. In other words, and it would say the Windows nodes I can't run. These pods are not tolerated on Windows nodes because the Windows nodes have that OS taint on them. So taints and tolerations, you need to understand taints, tolerations, runtime classes. That's what you need to get your Windows pods scheduled. Okay. There's a whole other thing called the pod.OS field, which gives you an authoritative declaration of where a pod intends to run. That's great. That's for security and pod security constraints and all that kind of stuff. That is also important for security, but it's not important for scheduling. So it's important to keep these two things distinct. Now let's go and figure out this run HCS wcal process, because that was kind of the funny thing. So now I'm going to share my other screen. I'm going to share my web browser again. So here's the funny thing that I was just talking about that's kind of weird. So it turns out I think this blog post is still the only explanation of this run HCS wcal process. So what's that, right? So if I go in here, right, and I look for this, you'll see this in container D, okay? So inside of container D, all right, inside of container D, you can see there's these runtimes. So for config Windows. So there's a default runtime name called run HCS wcal process. And that's wcal stands for Windows containers on wcal equals Windows containers on Windows. Okay. So Windows containers on Windows. So I'm running a Windows container on the Windows OS. That's the normal thing you talk about when you talk about running Windows containers in Kubernetes. So this Windows containers thing, the way this whole thing works is your container D has different types of runtime options when it's starting container. And if you don't put the right option in, then you will run into a situation where container D will fail during startup. So let's watch that. Okay, so let's watch that happen. That'll be fun. So let's do this. So let's go back to Termius here. Let's change this, right? And let's go and let's change our deployment, right? I'm sorry, let's change our runtime class. So let's vim bad runtime called .yaml, okay? And let's cp runtime to bad runtime.yaml, okay? Now if I do bad runtime, you see I've told container D, this handler is going straight to container D and it's saying, hey, I want you to do it with this. But if I make some new thing that didn't exist yet, let's say I make some new, okay, handler, this isn't real. Okay, so let's say I make this. Okay, so now let's say I go and I say kubectl and let's make this a new name for this runtime, right? So let's say I make this, call this Windows bad, right? Okay, so now I could go and I could get a deployment, right? I could say kubectl edit deployment, who am I Windows, and I could make it use this other runtime class that sucks. Runtime. Right? So I could make this use the bad class. Now let's see what happens. Watch this. Okay, so I change this, and all these are going to roll out, right? So I'm going to see my everything roll out here. Why didn't it roll out? Okay, kubectl scale. I can just scale this thing. Okay, I forgot. I guess it doesn't. kubectl scale. Let's just delete one. kubectl delete pod. Let's just delete this thing. Okay. Let's just delete this one. Now it'll try to come back and it's going to fail, right? And now we can look at it fail. kubectl logs. Why is it not failing? Well, let's see. Okay, that shouldn't work. I don't know how that's working. That's so weird that works. Why does it work? Oh, that runtime class doesn't exist. Okay, that was weird. Let's delete it again. Now let's see if this... Okay, so it's still there. So now at least we have the runtime class. All right, we got the runtime class. And now if I look at this pod, this new pod that I just made, kubectl edit pod, this one. Oh, it's not using that. It's not using that weird runtime class. kubectl edit deployment. Okay, this is definitely the runtime class. So why is it that this thing, I'm going to scale this thing up and down. Oh, finally it's broken. I don't know why that was weird. Finally, there we go. That's what I wanted to see. kubectl now you'll see it. kubectl describe pod. Now you'll see the error. Okay, there you go. So there's no runtime. So what's happening is this is going all the way down to the kubelet. The kubelet is trying to start the pod. And then when it starts the pod, it tells us the containerd. It says, I want you to use this particular type of runtime. This isn't real. And then containerd says, I don't know what that is. I have no idea what that is. Then containerd blows up. And so the pod never starts. So to fix this, you have to actually have use the right runtime class. And if you do the right runtime class, then the original one that I made, okay, so that's terminating, and now the new one will come up fine. Yeah, so, well, nothing needs to come up anymore, but I can show you delete pod, this one. All right, so I can show you this one, and I'll delete it, and this container will come up just fine, because it's using the right runtime class now. Right, so now, of course, we want to be nice to our cluster, so we will kubectl delete ls kubectl delete -f the bad runtime, right? Because we don't want to ever use that again. So anyways, that's how runtime classes work. Okay, so so again, to keep in mind, runtime classes, taints, tolerations equals scheduling. Okay, so keep that in mind. Taints, tolerations, runtime classes are for scheduling, and then pod.OS is for security metadata on launch. Right? Different things. These you have to understand both to schedule Windows containers.